All right, welcome back, everyone. So, if you're in the data world at all, you know that SQL joins are pretty much your bread and butter, right? They're how we connect everything. But today we're going to go a little deeper. We're going to uncover this really clever technique, one that lets you find those hidden relationships in your data that are just sitting there waiting to be found. I mean, think about it, right? Your data doesn't live in one giant messy spreadsheet. Thank goodness. For organization, for efficiency, for our own sanity, we split it up into different tables. But that creates a problem, doesn't it? How do you actually unite all that data when you need the full story? Okay, so here's what we've got on tap. We'll start with connecting the data dots, then a quick look at the 4 essential joins. After that, we hit a really interesting one-table paradox. That's going to lead us right to the main event, introducing the self-join. We'll see it in action, and by the end, you'll have a new SQL superpower. Let's get into it. All right, first up, connecting the data dots. So the whole reason we even need joins is because our data is usually split up on purpose, right? You've got your users table over here, your orders table over there, maybe a products table somewhere else. That's just good, clean database design. But it also means we absolutely need a way to build a bridge between them. And that bridge, well, that's the SQL join. It's this awesome command that lets you just weave all that data together from different places. You just find a column they have in common, like say a user ID that's in both your users table and your orders table, and boom, you can create a single unified result. Honestly, this is the heart and soul of querying relational databases. So before we jump into our really special case, let's do a quick refresher on the standard toolkit, the 4 main joins that you're probably using every day. This table lays it all out pretty nicely. You've got your inner join, which is super picky. It only wants the matches. Then there's left and right joins, which basically pick a favorite table. And finally, the full outer join, which is kind of like everybody in the pool. It just grabs everything. Let's touch on each one real quick. So first up is the inner join. This is probably the one you use most. It looks at 2 tables and only gives you back rows where there's a match in both of them. You can think of it like 2 overlapping circles. The inner join is just that little bit in the middle where they overlap. Only perfect matches need apply. Then you have the left and right joins. They're basically just mirror images of each other. A left join will give you everything from the left-hand table, and then it'll try to find matches from the right. A right join, you guessed it, does the exact opposite. These are so useful for finding out what's in one table but maybe missing from another. And finally, we've got the full outer join. This one's the most comprehensive. It gives you all the rows from both tables, period. It'll match them up where it can, and if it can't find a match, it just fills in the blanks with nulls. It's how you get the complete, totally unfiltered picture of 2 data sets together. Okay, so you see how this is building. All those joins we just talked about, they have one really big thing in common. They connect different tables. But what happens when the relationship you're looking for is hiding inside a single table? Well, that's what I like to call the one-table paradox. And here's the classic example that makes it all make sense. Imagine you've got one employees table. It's got everyone in the company. But in that same table, you have a manager_ID column. So how do you find out the manager's name when all the clues are in the exact same spot? Check this out. See Frank Kappa? His manager ID is 8. To figure out who that is, we have to look right back at the employee ID column in this exact same table. And there he is, Mike Dyson. The relationship is right there staring us in the face. But how in the world do you write a query for that? And the answer to our little paradox is the self-join. It is such an elegant and, frankly, brilliant way to solve this exact kind of problem. Now, a self-join isn't a new command you have to learn, like inner join or left join. It's a technique. You're just using a regular join, but you're joining a table back to itself. It's the perfect way to handle things like org charts or to compare different rows inside the very same table. And this quote right here, this is the whole idea. This is the mental leap you have to make. To pull off a self-join, you have to pretend, just for a moment, that you actually have 2 separate identical copies of the same table. So how do you actually do it? It's really just 3 simple steps. First, you just call the same table twice in your query. Second, and this part is absolutely crucial, it won't work otherwise, you have to give each one a unique nickname, an alias, like E1 and E2. And third, you just write your on condition that connects the two aliases, like linking the manager ID from one to the employee ID on the other. Okay, that's the theory. Kind of cool, right? But now let's see just how powerful this is with a real-world business case. We need to find all the users who made a second purchase pretty soon after their first one. So here's our data, a single table with all the transactions. You can see right away, user 120 bought something on March 18th and then again on March 21st. To find this kind of pattern for all our users, we need to compare a transaction row for a user against all the other transaction rows for that same user. And this query is how we do it. So let's walk through this. Notice we call Amazon transactions twice, giving them those nicknames A1 and A2. We're treating it like two tables. Now, the real magic is in that on clause. First, we link them where the user ID is the same. That's just to make sure we're looking at purchases from the same person. Then, and this is the really clever bit, we add another condition. We're asking if the purchase date from our second table, A2, falls somewhere between the date in our first table, A1, and 7 days after that. And just like that, we can find that repeat purchase within a week. And boom, there's our result. A nice clean list of just the user IDs who did exactly what we were looking for. The self-join was able to compare rows inside the same data set to pull out a super valuable business insight. So you see, this isn't just some weird niche trick. It's a genuinely powerful new way to think about your data. Let's just wrap up with the most important takeaways. Okay, remember this. A self-join is a technique, not a whole new command you have to memorize. It's your absolute go-to for any kind of hierarchical data, like org charts, or anytime you need to compare rows within the same table, like finding those repeat customers. And the absolute key, the secret sauce, is giving that one table two different aliases. That's what unlocks the whole thing, letting you treat it like two separate tables for your query. So now that you've got this tool in your belt, the possibilities are pretty much endless. I want you to think about your own data sets, your users, your products, your logs. What kinds of patterns or sequences or hierarchies are just lying there under the surface, waiting for you to find them? Go find out.